Hi friends, welcome back to another Tech Tuesday. Today I'm actually going to briefly talk about sprites and moving objects in Donkey Kong. This is a topic that I learned a little bit about today just because I'm in the middle of writing this test ROM for Donkey Kong after having a bit of conversation on Clav. I learned a little bit about DMA and how Donkey Kong handles sprite information. So, um, to start off, our moving object information is actually stored in these two RAMs here at 6P and 6R. They are 2148 SRAMs. They're both 1K by 4 static RAMs, kind of similar to 2114s, but these are a bit faster. Um, Essentially, the way it ultimately works is either the DMA controller can copy over data directly into these RAMs, or the CPU can write to it. What's interesting, though, is that DMA, although it can technically occur anytime, at least in the Donkey Kong ROM set, is only called during vertical blanking, which has an NMI, or which is synced with NMI. So that's when it does these writes, which is kind of interesting. So um, basically, when the CPU or DMA controller needs to write to it, it will select all these muxes to be at the address lines, and it will send a write signal to write to these two RAMs. During normal operation, though, or during when the video board is using the information, it will actually only, or it'll be using these horizontal counters for the address lines because it's using the information on this RAM to print to the screen. I'm not going to really get into talking about how it processes this object information because, truth be told, I don't really know. That's all there is to it. However, I can show you a little bit about, the sprite itself. So, um, earlier today I was farting around in MAME. In MAME, you can actually use a memory window in the debugger and manually print a sprite to the screen. So what's interesting is the sprite information is separated into 4 separate bytes. There's an X and Y coordinate, and then there's the sprite ID, and then there is the palette select. So in the MAME debugger, let's just say I want to print Jumpman to the screen. I could manually just type an X coordinate. 0 is the sprite ID for the Jumpman. You can actually see he's up here in the top. So we're going to leave it 0. So we can actually change it to 1 because it starts his walk cycle. And you can see that it actually updated. There's all sorts of different parts. Let's move them down. So we're going to move them to about the center here. So that would be 80 in hex. Oops, I typed it in the wrong place. That'd be 80 in hex. And you can see that it's actually the climbing sprite. So we're going to go back to 0. And because this doesn't look quite right for Mario, or I'm sorry, Jumpman, we can change the palette to hex 2, and it actually looks to be correct for it. There is these, or the lower 4 bits of this byte are they're for the palette itself, so it'll go all the way up to F. So that's F, but 2 is correct here. And then the upper bit, or the uppermost bit on this actually flips the sprite upside down. So just a little bit of a fun thing to try out. So while learning about this, I actually wrote a little bit of code to kind of play around with the sprite objects, or the sprites. So if I enter my sprite test, you can see that all I'm doing is just moving them around on screen. There isn't really much to this kind of a test, and it would be good enough to, or it'd be good enough for testing the data sections after the sprite RAM itself. I apologize, I'm switching between the terminology sprite and moving objects. In this instance, they're the same. It's also not to be confused with video RAM, which is actually what this text is. So that is technically a background object, I believe. It's technically a background object, and the sprites move in front of it. So that's something else to keep in mind. So for this, it's not really that complicated. I basically just write the coordinates here, the x coordinate, the y coordinates, and then the sprite and palette. And then every time NMI triggers, it ends up at the sprite handler here, which prints the current position and then processes, you know, it reads the controls. The controls are using the in0, which I believe is 7D00. We can double check actually, because I have it set as a constant in here. I apologize. I just want to make sure you have the right info here. So I see, that's why we double check. It's actually 7C00. 7D00 is in2, and 7D00 can be read to refresh the watchdog as well. So once we read the controls coming in, I can just process it by either incrementing or decrementing the x and y coordinates. And when we press the jump button, we actually return back to our runtime test. So if I press the jump button, it goes back to this, to where everything else can be done. So yeah, I know this is a bit of a scatterbrained kind of video, but this was something quick I wanted to show you. I hope you found this kind of interesting. I'm still working on the test ROM. It is available on my GitHub, or at least the development builds. I'm hoping to finish this up within the next couple weeks, definitely by the end of the month. So anyway, thanks for watching. Have a good one.